I see you're watching that video we shot a few weeks ago.
Yes, I am. That's a solar air furnace that was invented by a fellow by the name of Dale Schneider back in the 70s after the Arab oil embargo of '73, when the federal government was giving tax credits for all kinds of energy-conserving devices. He just came back to Michigan to find these units 30 years later are still functioning on people's homes, still giving them the same kind of service. So now he's looking at not just residential, but also commercial and industrial. It's very exciting.
Let me see here. So that's north, right?
Yes, sir.
So this is south going this way.
Right.
Okay, so it's a little south and southwest.
A perfect sighting for 2:30 in the afternoon.
Okay,
great.
Basically south by southwest.
So this is a, what is this, 4x8 glass panel here?
Yes, it is. Taking the outside air in and distributing it underneath this solar panel.
You wouldn't have a frame like this per se.
Yes, that wood frame would be sitting right down on the roof.
I see.
And then as it's delivered to the job sites, these side panels, which is this panel and the other side, is shipped to the site, as well as the back panel.
Okay.
And the other next thing would be the solar panel. So we install this as the first operation, which is our roof curve.
Right.
Which is very important to be flashed in, so we have waterproofing. And from then on, we have our people that will take and come to the sites. Cranes will be there sitting on sites. All materials will be delivered up to the top of the area. And from then on, we will have crews. And believe me, and we're talking about one situation where it happens to be 1 million square feet, it would be roughly 1,000 panels that would be delivered over to automotive. And that will be done within a couple months' time. We'll have the whole operation completed and ready for them for the winter.
Is about 71 to 72 degrees. That's the outside air temperature coming into this unit.
So Bill, this is saying it's 70 degrees outside, and that's what's going into this.
Yes, sir.
Okay, so now it's...
I'll turn it on.
Okay, it says 80 degrees.
80.
Very, very short period of time, that 71, 72 degree air will go up to well over 150 degrees. And that's happening right now. They turned it on, the fan is going, it's pulling this 70 degree air through it, and in practically no time at all, it's over 120 degrees. We picked up basically 87 degree delta T, an 87 degree Fahrenheit change in temperature from the 71 degree entering temperature to the 158 degree leaving temperature.
So is it still possible to get a 90 degree bump even in the winter?
Sure is.
You're kidding.
That at temperatures of 40 degrees, they had 155 degrees leaving, which is a change in temperature not of 87 degrees, but of 115 degrees. And they did some other tests at 20 degrees, and they had 165 degrees leaving. So the delta T there was 145 degrees. So at the higher temperatures, we were getting 80 to 90 degree delta T. At a lower temperature of 40, we were looking at about 115 degree delta T. At a temperature of 20, we were looking at 145 degree delta T. And this may seem not quite congruent. It's like, it's not, common sense says, how can you do this? But in reality, from the physics and the heat transfer and the thermodynamics of what's going on, it's the change in conductivity from the colder the air, and you're going through the same amount of heat, you can actually get a higher delta T because you've got a greater temperature difference from that entering air temperature. It's actually fascinating, but true, that as the temperature of the air goes down, the change in temperature between the entering air and the leaving air becomes greater.